Hello everyone, I am Kazi Hassanul Safa. Today I will discuss about machine learning assignment 2. This assignment is a step-by-step process to implement a multi-class classification using ID's classical dataset. The idea of the current assignment is to intensify what we learned in deep learning. Firstly, I imported pandas as PD. Then I connected my IPYNV file with my Google Drive. And this is my link, and I saved this link in a variable called file name. This is my iris.csv file. Then I read all the data from my CSV file, and I showed first 5 rows from my CSV file. This is my CSV file, first 5 rows. Then I converted the last column string to integer as Setosa to 0, Versicolor to 1, and Versenica to 2. You can see last column, all values are string. Then I again showed first 5 rows from my CSV file. If you go to my CSV file, first 5 rows, all values are Setosa. That's why all values are 0. Then I saved first 5 columns value in a variable, and the variable name is X. And I saved last column value in a variable called Y. You can see 100, 145 rows, the value is 2. It means it is a Versenica. After that, I imported train test split from scikit-learn.model selections. Then I splitted the data X and the label Y into training and testing segments and called them Xtrain, Xtest, Ytrain, Ytest. And I showed their value. Xtrain, this is my Xtest, this is my Ytrain, and this is my Ytest. After that, I showed Xtrain length is 120 and Xtest list value is 30. So I believe my value is perfect. Then I converted Xtrain and Ytest into categorical and called them one hot trains labels and one hot test labels. Then I printed both variables. Then I imported layers and models from Keras. I defined a sequential model that contains 3 dense layers. The first and second layers, the hidden units is 100 and a ReLU activation function. The last layer I used 3 because I have 3 classes like Setosa, Versicolor, and Versenica. Then I compiled my model here. After that, I fitted my model using epoch equal to 20 and bash equal to 10. Then I calculated my result and evaluated X test and one for test levels. After that, again I fitted my model using epoch equal to 20 and batch size 10. In number 9, I repeated number 6. For first and second layers, I use 10 hidden units and ReLU, and third layers, I use 3. Then I compiled my model and I fitted my model using epoch equal to 4 and batch size equal to 10. After that, I evaluated my model and fitted my model here. Here epoch equal to 4 and batch size equal to 10. In number 10, I answered 3 questions. First question is impact of hidden layer of our model. Second question is, do we have always suffer from overfitting? Third question is, how can we find and manage overfitting? In general, we have more number of layers or hidden units. We can get more accurate model. For second question, overfitting refers to the situation when a model fits too well to training data but fails to fit to new data. For third question, a very good indicator of overfitting is high accuracy and low error rate for training data, but low accuracy and high error rate for testing data. We can avoid it 6 ways, like early stopping, training with more data augmentation, feature selection, regularization, ensemble methods. To avoid overfitting, we can train the model with more data and reduce number of features or parameters to make model less complex by decreasing any redundancy. Then I repeated step 9 and changed the number of layers and compile parameters. Here you can see my parameter is 60. Here parameter value is 50, and last layer I use 3, and I compile my model. Then I fitted my model using epoch equal to 18 and batch size equal to 10. Finally, I calculated my result and evaluated. That's all for today. Thank you for watching my video.